So now that we can write capital M molarity as a conversion factor, we're going to use this to answer the question. How many milliliters of 0.625 molar potassium iodide to react with 35 milliliters of this lead 2 nitrate? So my unknown, X milliliters of potassium iodide, and my known, remember my known will always have one unit, not two. The lead 2 nitrate, I have 35 milliliters and I have 0.815 capital M. Capital M, remember, has 2 units. That's a conversion factor. So we never want to start with capital M. We want to start with 35 milliliters because that only has 1 unit. So now I need a conversion between milliliters of lead 2 nitrate solution and moles of lead 2 nitrate. And that conversion is the molarity, 0.815. So 1,000 milliliters of that lead 2 nitrate solution contains 0.815 moles of lead 2 nitrate. Now once I have the moles of any chemical in the reaction, I can turn that into moles of any other chemical, in this case potassium iodide, as long as I know the ratio, and it's a 1 to 2 ratio from the coefficients of the balanced chemical equation. So 1 goes with the lead 2 nitrate and 2 goes with the potassium iodide. But now I want to keep going to milliliters. So for moles of potassium iodide, I want to turn those into milliliters of potassium iodide solution. And the key there is capital M molarity. 0.625 capital M means 0.625 moles of potassium iodide if I had a liter, which remember is 1,000 milliliters of potassium iodide. So it's very similar to the stoichiometry problems we worked in the past. Instead of starting with milliliters, we usually started with grams. Instead of using capital M as our conversion factor to turn those grams into moles, in the past we used the molar mass, which we got from the periodic table. Now we're using molarity. The mole to mole ratio is the same type of conversion that we saw before, and then this last step, because we're dealing with another solution, we're using capital M molarity. But you might have a problem in this same reaction where, let's say we were trying to figure out the theoretical yield of the precipitate. This is a solid, not a solution, so if we wanted to turn moles into grams, we would go back to the molar mass from the periodic table. You just have to realize what kind of chemical you have. If it's pure, you can use the periodic table. But if it's a solution, then you have to use capital M molarity. So to finish this one off, if we multiply it all out, we should get an answer of just over 91 milliliters of potassium iodide.